Welcome to the presentation of our project Modular Syntax Translator for Assembly Verification. This short video has been recorded with the goal to demonstrate our program. The main functionality of our program is to translate assembly instructions into C instructions, and the main property is that it is extendable. There are two main inputs for our project. First of them is the input file with assembly instructions. Here we have 14 categories of instructions, and under each category we have a set of assembly instruction. For example, we have logical register instruction, OR, XOR, and AND. Another example is a logical intermediate instruction, OR immediate, XOR immediate, or AND immediate. These instructions take an immediate value as an argument. Then there are the other instructions. The second important input for our program is the architecture declaration file. Here we define the variables which are important for the translating process. One of them is the general purpose register. Here we give the short name GPR. This GPR will be used by any instruction that uses the general purpose register. This variable can differ from one architecture to another. Another important variable is the register prefix. At that moment, we declare it as with small r, capital R, Y, and %R. Of course, we can add or delete some of them. All of them are acceptable as register prefix in the assembly instructions. Let's save the architecture declaration file and see how the program works. As requested by the client, there is no graphical user interface. The program can be started by the command line. Here we have to type Java, MST, which is the name of our project, the input file name, in our case it's input.txt, and we have to specify the architecture in which we want to translate. Let's take, for example, PowerPC. And at the end we have to specify the output file name. By pressing enter, we execute the program. Our file has been successfully translated now. Let us make a comparison between an input and the output file. As you can see, each row from the assembly instruction file has been translated in the output file in C instructions. Some of these instructions are easily translated, like the comment on the first row, for example. It is kept exactly as it is, also in the C file. Let us take a look further in the file. We have on the next row OR, and here we specify the name of the register. We take the name of the instructions as the name of the function in C, and we take the name of the indexes of the register in assembly instructions as an argument for the function in C. And here we can see that we use both of the register prefix, small r and R capital. Here we make OR between the register R2 and R3 and put the result in R1 register. The same could be seen in the immediate instruction, where one of the parameters is immediate value, like here, for example, we have OR between the value stored in R2 and the value equal to 12, which is binary. The result is stored in R1. This was an example of an easier translator instructions. Other instructions are more complex to translate, like, for example, the branch value. Here we have branch -20, which means to divide this value by 4 and to take the result, which is 5. The minus in front means that we have to go backwards with 5 steps. This is taken from the result. On that place we have to add the new label to which B will point. If we go further in the file, we can see that we have two instructions that have not been translated into the output file. This is because they did not match to any of the defined patterns. We did this on purpose in order to show that our program is extendable. This could be done by adding a new pattern and a new definition for a new instruction. This declaration can be easily defined in the architecture declaration file that we have already seen in the beginning of the video. Here we have prepared two examples of pattern. We have to copy them and paste it in the architecture declaration file. Let us take a closer look at this pattern. We start with the instruction name, followed by the space, then specify the register prefix, which can be one of the defined up values. Then it is followed by a number. This number is the register index. Then it follows by space, comma, space, again register prefix, number, and space again. Let's go on the second row. This is the instruction name. It could be move with small letters, move with first letter capital, or move with all letters capital. On the next line, the rule is specified. It starts with GPR, and then the number of the variable number 3 from the pattern we have to take and to put it here. Then we take the variable number 5 from the pattern, which in that case is number, and place it also here. Now we have to save the changes and to rerun the program again. We go again to the command line, type the same, press enter, and again our output file have been successfully generated. Let's go down to in the output file, and here we can see the last two rows which has been translated. This was a short introduction of how to use our program. If you have more questions, please contact our client to refer to the submitted from us documentation. Thank you for listening and watching this video.